Hello, in this video we'll be looking at a question from the A-level paper 1, more specifically paper 1-2 from the year 2023. This is the question we'll be looking at today, and I'll be doing the solution out on the whiteboard, hopefully just like your teacher would if you were in school. If you were looking for another question from this paper, you should be able to find that in a playlist below the video. Okay, let's get to this question. In question 8, we're going to be dealing with graphs and trigonometric expressions. They're going to ask a few questions revolving around that. Now, this question, it's quite difficult, but it's also short. It's one of those hard questions. If you know what you're doing, it's really quick and easy. And if you don't know, it's very hard to even get attempt marks. So I'm going to bear that in mind and try and explain everything I do to help you along. Okay, in part A, it simply asks us to draw a sketch of the y equals inverse f. So here's fx, and this is the drawing of fx. They've given us this in the paper. And they want us to draw the inverse of x. Part B, they're going to ask us to work this out in maths. But for now, they just want us to draw it. And when they ever say sketch, it means you don't have to be exact. Okay, we don't have to be perfect in this answer. Okay, with that said, the inverse of a function. There's two ways to do this. You can think of a function as you put x in, you get y out. I put 0 in, I get just under pi out. I put pi in, I get... Also, sorry, I must say, their drawing has a graph, it's exact. It's hard to do that on the board. I'm not going to spend an hour drawing all the lines, well, 5 minutes drawing all the lines. So forgive me if my drawing looks a bit wrong. Some of the numbers I might say now could be a bit wrong, but the general idea should work. So when I put pi in, I get just under 1.5 pi out. And so on. That's how this sort of function works. X goes in, y comes out. The inverse is the opposite. The inverse would be this number going in and this number coming out. So if I put pi in, or just under pi, I will get 0 out in the inverse function. So we can just go ahead and start drawing that like this. If I put just under pi in, I get 0 out. If I put in somewhere between 1.5 pi and pi, if I put that in, I get out just under half a pi. So if I put in here, I get out something here, and so on. I can stay going for all these. This one should be the easy one. If I put in, so I put in 2 pi, I got, what's this? Somewhere between 1.5 and 2 pi out. So if I put in that, I should get 2 pi out, and so on. I hope that's clear. If I put in all these dots, I should get a shape that looks something like that. Okay, so that would be full marks for this question. If you did that, just keep put points in and turn. Yeah, let me say that one more time like this. So this number here is about 3. It's actually exactly 3 now that I think about it, but it's about 3. So if I put 0 in, I get 3 out. So that's 0, 3. That's what remember, pi is 3.14 and so on. And so this number here is 0, 3. This number here is 3, 0. This number, let's see, this was the original here. 2 pi, which is 6.28, goes in. And the number that comes out, I won't try and make a guess, so I'll get my calculator. Well, I guess I'll half guess it. 2 pi goes in. Something like, I don't know, 1.7 pi's come out, and that is about 5.3. These are just rough numbers. 5.3. So the opposite, the inverse, would be 5.3, 6.28. Okay, I hope that gives you an idea on what I mean there. Numbers went in, numbers came out, switch them around, and that's what the inverse looks like. And that's roughly what it looks like there. Another way to have done that is to get the y equals x line, the middle line. Pi over 2, pi over 2. pi and pi, and so on. You get this line here through the middle. And you can do this in an exam. They just wanted a sketch. They only want a rough idea. Everything's the mirror through this. Put a parallel line. Get your set square in an exam. You should have a ruler and a little set square. And you can put your ruler along this line and your set square. Draw straight lines through. Straight lines through. And measure this. Compass, swing it around, get this point. Compass, swing it around, get this point. Compass, swing it around. This point's the same. Compass, swing it around. What's my drawing here? It's not quite right. Should be a mirror through this line. That would have been also full marks, and that should only take you a couple of minutes. I wouldn't just really roughly sketch it. In theory, you should get full marks for roughly sketching it, but I do a few measurements. It is an exam after all. Okay, hopefully that answers everything from part A. Let me just rub this out here and we'll do part B. Okay, for part B, they ask us to find, let me just read it, find an expression for the inverse. So I've rubbed out fx here because I'll replace that with y equals. I don't have to, I could have left fx there, just y is a bit easier for what I'm about to do. So how I get the inverse, and it's roughly how everyone does, they just say it's slightly different sometimes. I just try and switch the x and y. That's it. I try and switch the x and y however I can. Basically I get x on its own in some sort of function with y. Let me just go ahead and do that and I'll explain what I'm thinking. But it's roughly what I said before. The x and the y just switch places. That's what an inverse is. So to solve this, I bring the 3 across. Y minus 3 equals 2 sine 1 over 4x. Bring the 2 across. I get y minus 3 over 2 equals sine x over 4. I'll just write that as. Get rid of the sign. Let's take the inverse sign of both sides. So I get the inverse sign of y minus 3 over 2 is equal to x over 4. And multiply both sides by 4. And let's just write it the other way around as well. X is equal to 4 times sine, inverse sine, y minus 3 over 2. And that's, I would accept this as full marks. Although the examiner probably wants you to do one last thing. This is an inverse function. This is the inverse of this one here. It's just we're using the wrong letters. We always, just as a matter of, it's just what's done. We always, the variable that goes into the function, we use x. And the variable that comes out, we use y. So let's just fix that by changing those letters. Y is equal 4 minus sine 1 x minus 3 over 2. Now, if they didn't give you full marks for this line, I would be willing to go in and argue my case, but let's not argue our case. Let's just do the way 99.99% of all mathematicians do it. Let's just write y and x. But anyway, that's your full marks for part B. Okay, for part C, they've given us the same picture again, but they've zoomed out a bit, and they've asked us to complete the sketch. With this domain here. Basically, they want us to complete it on the left side, all the way down to minus 2 pi. And then they ask us to explain whether the function has an inverse or not. Okay, I can see two ways to do this. The first way is probably the way you should do it, and the second way is how I would have done it, but the second way also answers part D. So I will do both. First, I will do the way you probably will do it, and then I will do the way that will answer part D. That way we'll do two birds with one stone. Okay, so the best way to simply do this is the exam is giving you lots of points here. Split this up into many parts, minus a half pi, minus pi, and so on. My advice is just put those numbers into this equation. Put it into a calculator. And I've done that here for a few of them. For minus a half, you get about 0.7 of pi. Actually, my drawing's not good enough to put this in, so forget that. For minus pi, you would get about half a pi or so on. And basically your drawing will end up looking like this if you put in, and this is again putting in just a few points. Put in a few dots for half pi, pi, 1 over half pi, and so on. And that would be your marks. What's this, 2 marks for this question? That would be 1 mark for doing that. And then just explaining why you think it has an inverse, or doesn't, whichever the case may be. So they want to hear you say something along the lines of, x goes in, only 1 y comes out. And if the inverse would be y goes in, only 1 x comes out. And nothing stops that happening. So what I mean by that is, if minus 2 pi goes in, you know what the answer gets you something down here. It's I guess it's 1 exactly. If 2 pi goes in, you get 5 out. If 0 goes in, you get 3 would come out, and so on. And you only get 1 answer in and out. Just as an example, here, if you put every number that goes in, you get 1 answer out. Every number that goes in, you get 1 answer out. But this doesn't have an inverse because the opposite is not true. If I were to inverse this function, put this number in, I get more than 1 answer out. I get these two. So that can't be a function. A function can't work like that. You put 1 thing in, you get 1 thing out. So the inverse of this doesn't work. The inverse of this one does work. So the examiner wants you to write something like that. It doesn't have to be an essay. The magic words they are looking for is x and y are unique. I guess 1 to 1 would be the fancier name. 1 to 1 and on to. I'd have to check the exact terms they're looking for. But they wanted to explain something like that, a function. Unique. 1 goes in, 1 goes out. And that does work in this case. The real thing to look for is this. Things that have 2 answers if you draw straight lines. So if you draw straight lines like this, they're all okay. If you draw straight lines like this, it's not okay. That's why you never see a function in maths that looks like this. They're not functions. It's not a function. It's something that can be of interest, but it's not a function. Okay, let me clean this back off because I want to answer this question again, how I drew this. At the same time, I'll answer part D. Okay, for part D and for part C, when they asked me to finish this sketch, the first thing I thought to do was this sketch. I thought to sketch sine x, and that would look something like, let's go all the way to 2 pi. Up to 2 pi, and let's do it the other way, down to minus 2 pi. Basically, I decided to draw this picture and this function, and this is how I do this. I wouldn't do it too exactly, it'd be a quick sketch. Next thing I would do is, hope I don't run out of room here, then I would draw sine x over 4. And how do I do x over 4? I think of what goes in. If 2 pi goes into this, 2 pi divided by 4 gives me pi over 2. And here's pi over 2 here. Here's pi. So if I put 2 pi in to this function, it'd be like putting half a pi into this one. So I should get 1 out. And the same if I put in pi, it should be the same as a quarter pi. Getting this out. Basically, I'll get something like this. I just had to replace my pen, so let me redraw that. Something like this, and that would continue down. I'm going to run out of room, so I better be a little more economical with space, and minus 2 pi. And then the last thing I would do, let's do this once more. I'll fake the room in here. Last thing I would do is I would draw I'm definitely going to run out of room because I have one more to do. I'll do it over there. Next one I would do is 2 sine x over 4. And let's see, let me make a little more room here. Hopefully you'll get the idea. It is only a sketch after all. 2 times sine of this is this, the height of this was 1. Height here was 1. 2 times it will end up going up to 2. There's 1 down here. And it will look the same, it will just get stretched up. And that'll go down to 2 pi. And that'll go down to minus 2. And then the last one I would draw, I would usually do these all on top of each other. But I would do it very roughly. Like again, this is just for me. It's the last one that I need to be right. And even that I can do it again up here. Exactly right. So the last thing I would do, instead of 2 sine this, I would do 3 plus 2 sine x over 4, which is the one I want. And that's just this moved up 3. So we would here be at 3 and we would have this shape. We would have this shape, that would be 1, the top would be 5. Which is what this is, which is what this drawing up here is. Instead of 5 though, I guess you'd have to divide everything by pi. That's where we get, so this number up here is 5. It's just done in terms of pi. This bottom here is 1. It's just done, and it's written as pi. Like 1 is in pi would be 0.3 pi or something along that lines. So anyway, that's how I would have sketched this. I would have done it through these 3 steps. And that brings me on to part D. Part D asked me, how would I get from sine x to 3 plus 2 sine x over 4? Or how would I get from sine x to, I think they say gx or fx, the original function. Oh, you know what, they never cared about the left side. Yeah, they never cared about the left. I could have saved myself a lot of space here. So how would you get from this function all the way down to this function if I rubbed out the left side of all of them? Doesn't change anything. And what they just want you to do, they want you to, you don't have to draw these, they just want you to say something like stretch. How do I spell stretch? That's roughly right. Stretch times 4 in the x-axis. Stretch times 4 in the x, because that's what that is doing. That's just, like if I could finish this on here, it would still look like a sine. It's just being stretched out. The difference between this one and this one, it's just been stretched again. This times 2. Stretch times 2 in the y-axis. Stretch times 2 in the y-axis. And then finally, what have we done? We've just moved it up. So you can even write move, but the fancy word is translate. Translation. I hope that I spelled that right. Translation, I guess you could write it like 3 in y-axis, in y direction. Or you could write it as translation 0,3 is the fancier way to write it. And that's it for part D. That's all they wanted, these 3 sentences. Stretch times 4, x-axis, stretch times 2, y-axis, and translation 0,3. They didn't need these drawings, but I just wanted to show you because this is how I'm able to draw any function, any simple-ish trigonometric function. I always just start with, in this case, sine, because it was sine, and I just stretch it, pull it, move it until I've got the function. So you will be asked in your exam to draw some weird function. So it's really useful to know how to do these steps. Okay, I hope that answered some of your questions in this. You might have follow-ups. If you do, put them in the comments below. I'll do my best to answer, or maybe somebody else will answer. Until next time, have a great day.